This is Team 24, and our project is Informatics in Construction. My name is Tianlong San, and I'm a senior in structural engineering.
My name is Scott Yandel, and I'm a junior in environmental engineering.
My name is Rami Mehta, and I'm a junior in structural engineering.
Okay, so our project, Informatics in Construction. Informatics is an applied science that studies issues specific to construction. More specifically, it's the communication of construction information between humans and software. It is information support for several life cycle phases, including documentation, management, and economics. Another name for it is construction IT. Two main ways that this information can be gathered is through the use of GIS and drones. The purpose of this information is to give a clear idea to the builder and designer of a site's layout through mapping data. Drones are becoming more common on job sites because they provide an aerial view. Through photographs, they assist in planning and surveillance. As the project progresses in its construction, drones can provide views for inspections, site monitoring, and assist in communications between designer and builder.
So, GIS. GIS is a system made up of computer software and various functions which is used to support the collection, processing, analysis, and modeling of spatial data so that complex planning and management problems can be solved. It is also used for risk and hazards assessment to prevent accidents from happening. BIM and GIS are two critical technologies whose integration can bring exemplary results into digital construction. BIM offers detailed 3D visualization and the ability to organize huge volumes of data related to buildings, and GIS is highly customizable and well equipped for analysis, which makes both of them very complementary. For LiDAR, it uses a sensor to detect geographic features from above, creating an extremely precise 3D map of the region. Due to the way that the technology works, aerial LiDAR can cut through things such as bush and vegetation to properly map the ground. This is ideal for environments that have a significant amount of overgrowth, as otherwise the construction company may not be able to plan ahead for the terrain that is there. The data produced by LiDAR can be imported directly into construction and architectural software solutions. However, it could be costly and difficult to interpret. The use of sensors in construction. Just like GIS and LiDAR, sensors are very useful for analyzing and optimizing data from environments and construction sites. Furthermore, it can be used from long distances, which prevents workers from getting injured or hurt. There are known and unknown factors to these though. All these data collecting technologies are very useful and efficient. However, it is very vulnerable to wild animal attacks, which shortens its lifespan. In addition to that, it is costly to train workers to use and operate those tools. Due to the big increase of their popularity, GIS, BIM, and LiDAR, regulations and rules could start to limit their usage due to the potential risks of being misused by hackers or other criminals.
So the informatics in construction have a lot of meaning to current and future construction industry. For current construction industry, due to the development of communication technology with a drone, the site location and client distance can be significantly reduced, so the client will be able to see the job site within a few seconds. And then with its unique bird's eye view in drone, it makes construction scheduling and progress control much easier than before and saves a lot of time. And then with the feature of mapping and surveying in the drone, it provides much more accurate results and save a lot of time comparing to the traditional mapping method. So for the future construction industry, the drone can be developed to help the construction worker to do high elevation construction work so that the risk of injury can be reduced. And there's also some issues and challenges related to GIS and the drones. So for example, the GIS has lots of hardware and software, so it can be quite expensive. And with its complicated structure, the GIS can have some trouble to integrate with traditional maps, so a lot of useful and important information might be missed. And then, due to its complicated internal structure, an internal outage may lead to significant damage to the system, and it can take a lot of time to bring the system back. And the whole process of storing and collecting data can be very time-consuming and tedious for GIS use. As for drone, the data that's stored in the drone can be easily stolen, and it's a big loss for the company. And then, due to the high cost for training operators, there might be untrained operator in the company, and it can lead to collision in the drone, and it's also a big money loss for the company. And recently, there are more and more legislation to regulate the use of drone. So in the future, there might be more limits on the size and use of drones. So in the end, there's a case study about the use of mapping technology in drone. So there was a one 15-kilometer highway surveying solo project, and it was done by a company called Corvus Monitoring. So the motivation for this project is because there was a disagreement between roading authority and the local government. So the company was asked to draw the boundary line for the property for those two, for the roading authority and the local government. So the results turns out to be twice as fast comparing to the traditional method, and it's much safer than before because the worker don't have to cross the highway all the time. And it saves a lot of money and time to help the roading authority and local government to reach an agreement. So the last slide is our references for this project.